Hello juniors, today we're going to continue with electronic assignment 18, which is about the normal distribution. If you remember, the normal distribution is this. It's a bell-shaped curve that describes the distribution of a particular variable of study, right? And if you take a look at the bell-shaped curve, you would remember that most of the values in a normal curve distribution are clustered in the center of the data set, okay? We have seen some real-life examples where normal distribution applies. And then we have seen some characteristics of normal distribution. Remember the notation, whenever we have this variable, for example, is normally distributed, this value over here represents the mean of the information, and this value over here represents the variance, right? If you take the square root of this value, you would get the standard deviation, which in this case would be 2, okay? Then we have seen that the area beneath the normal distribution represents the probability of occurrence of a particular event. And we have seen this distribution, which applies to normal curve distribution, right? If we are one standard deviation below and above the mean, we tend to have 68.27% of the information. 2 standard deviation, this percentage over here, and 3 standard deviations below and above the mean, we would have 99.73% of the information. Then we talked about the standard normal distribution, which is a particular type of normal distribution where the mean is always equal to 0 and the standard deviation and variance as well is equal to 1, okay? We're going to be using this a lot later on, and you'll understand why. Okay, so for today, I want to see some exercises about a normal distribution. I'm going to show you how to use calculator to solve these types of exercises. Okay, so for part A, it says, given that the variable C is normally distributed with a mean of 0 and standard deviation of 1 or variance of 1, let me write this for you to remember. This is mean, and this is the variance, right? All right, like this. Variance. Remember the mean, I'm going to change this. The mean is represented as mu, the Greek letter mu, this one. Mu, which represents the mean. Okay, so how do we find the probability of C being in between -2 and 1? Okay, the first thing that you need to understand when solving these types of exercises, let me write this down, probability being between -2 and 1. It's better if you make a quick sketch first of all to understand what this is about. If we draw a normal distribution, let me draw that normal distribution right here. This would be the y-axis and the x-axis over here. I don't really need to draw the y-axis, but that's fine. Let me erase this. If I draw the bell-shaped curve, it will be something like this, right? It always has this shape, right? And the value in the middle, the mean value in this case is 0, right? So this is 0, and we have a standard deviation of 1. And if I want to find the values in between -2 and 1, I know that -2 is to the left of this value of the mean, right? This is only a sketch, so I'm going to put it anywhere. -2 and 1 is to the right, so maybe somewhere around here we would have 1. So basically, the probability that we're looking for is this probability, the area beneath this interval, right? This is the probability of the variable C being between -2 and 1, which is what we're looking for. So that's the graphical interpretation of the probability that we're going to be looking for. We're going to see how to determine that value right now. Okay, so to determine that value, we're going to be using our GDC. So using GDC, I'm going to write some steps here for you to follow. We would have to go to menu. I'm going to show you this in a second. Statistics. And then you go to dist. Just as binomial distribution, but now we're going to press norm instead of binomial, which we clicked before. Actually, this is like this, norm. If I take this a little bit down. and we're going to click on NCD, and I'm going to show you the difference right now. Okay, so let me show you this in the calculator. If you take a look at the calculator right now, we're going to go to Menu, Statistics, Dist, and instead of clicking on binomial, we're now clicking on norm, right? Norm. And here we have different options. NPD, just like BPD, is when we want to find the probability of an exact value. We're not using this as much as we did in binomial distribution for normal distribution. We're going to be using NCD mostly, and also inverse normal distribution, which I'm going to show you what that is about later on. Okay, NCD is normal curve distribution, which is used when I want to find an interval, right? A probability inside an interval. So we're going to click on this, NCD. And we have this information over here. Maybe at the beginning you will have something like here list, but it should say variable, okay? For data, you should always have it in variable. So then you're asked to plot in a lower value. In this case, our lower value would be -2 because we want to find the probability from -2 to 1. Our upper would be 1, right? Try to imagine the sketch we did in order to determine these values. The standard deviation in this case is 1 and the mean is 0. Okay, so this is fine. Once we have plugged in all the information, we click on enter, and there we have the probability. So the probability, let me write the answer right down here. The probability of being between -2 and 1 is equal to 0.819 if we round this to 3 significant figures. So this would be our answer. You see, it's quite easy, right? If you understand how to correctly sketch this. And this means, if we look at our graph, that this shaded region over here represents 81.9% of our information, right? The probability of being between those two values is of 81.9% in this particular problem. Okay? I hope you're understanding this clearly. Now let's move on to part B. Part B says the following. We want to find the probability of C being less than 1. Probability of C being less than 1. Okay. If we do our sketch first to see what's happening, let me copy this. It'll be useful. Let's use the same sketch. If we do a sketch of this situation, now we're going to have the following. Our mean is still 0. Standard deviation is still the same. So now we want to find the probability of being less than 1, right? So we're going to mark 1 here again. This is 1. And less than 1 are all the values that are to the left of this value, right? So basically we're looking for this region over here. All the values that are before 1, right? So we're shading this region over here. Okay, so how do we do this in the calculator? It's actually the same thing, but you have to consider something else. Let me show you this in the calculator. If we go to a calculator, we're going to go back. And now this is where you need to pay attention. The upper, it would be 1, right? It's our upper boundary. But for the lower boundary, you see that in the sketch, we're going to infinity to the left, right? To negative infinity. Because remember that the normal distribution has an asymptote. It never actually touches the x-axis. And that means that it continues towards negative infinity. So that means that we have to put a very, very small value as our lower boundary. And to do that, we put -9 to the power of 99. That would be a very, very small number, right? A number which is approximately negative infinity, right? You can always put this value as lower whenever this situation is considered, right? So this would be kind of like saying negative infinity. So you click on execute, and there you have the probability. So the probability of C being less than 1 is equal to 0.819. 4, 1. That means that the shaded blue region over here represents 84.1% of our information right here. Okay, so let me do that. Let me do the the observation here for the lower boundary. For the lower boundary, you should put, or you should input a very small value, like -9 times 10 to the power of 99. This would be a very small value. You could pick another small value if you want, and you'll see that the result is exactly the same. Okay, so here you have a screenshot of how the calculator should look for this particular situation. Then let's move on to exercise C. Exercise C says the following. We want to find the probability of C being greater than -1.5. So probability of C being greater than -1.5. So again, if we do a sketch of this situation, we're going to say that we're going to have our normal distribution, bell-shaped curve, right? Our mean is 0. We always have our x-axis here as an asymptote. So probability of C being greater than -1.5. -1.5 is to the left of 0, so it'll be somewhere maybe right here. This is only a sketch. It doesn't matter where you place this. So if we want C to be greater than 1.5, then we're shading all the region to the right of -1.5, right? We want it to be greater than. Okay, so we're going to be doing basically the same thing we did for part B, with the difference that now I'm having a lower boundary, but I do not have the upper. Well, the upper boundary would be positive infinity in this case, right? So if we go to the calculator, we would do the same thing, right? We go back here, but for lower, we're now going to put -1.5. We have the -1.5. We have the lower boundary. And the upper boundary, we see that it's positive infinity, right? So we're going to put a very big number, which would be +9 times 10 to the power of 99, right? Same thing, but with a positive sign. We click on execute, and there we have the probability. So the probability, let me write the information here. We're going to put as lower, -1.5. The upper would be 9 times 10 to the power of 99. The standard deviation is 1, and the mean is 0. Okay, so with all of this information in the calculator, we're going to get that the probability of C being greater than -1.5 is equal to 0.933. That means that this blue shaded region over here represents 93.3% of our information. Okay, this was an answer. This is also an answer. Okay, then we move on to exercise D. For exercise D, we have probability of C being less than 0. Okay, this is interesting. We want to find the probability of C being less than 0. If you understand what we're doing here, you should automatically know the answer for this already. If you take a look at the normal distribution, we're going to copy this. What are we talking about here? We want the probability of C being less than 0, right? But 0 for this particular problem is our mean already. So if we want this to be less than 0, then we're considering all the region to the left of the mean, right? The left of 0. And since the bell-shaped curve, the normal distribution, is a symmetrical bell-shaped curve, you should automatically know that this region over here, let me erase this, that this region over here must represent 50% of the information, right? It should be 50% of the information. You can check that in a calculator if you want. Let me show you. If we go back, in this case, we're going to put as lower negative infinity, right? Negative 9 times 10 to the power of 99. And as upper, we're going to put 0. And we should get as an answer 50%. You see? Probability equals 0.5. That means that we're doing this correctly, okay? So 50% is the result for this. We can, just by looking at the exercise and understanding the sketch, we know that it should be 50%. Let me write this as 0.5. 0.5, that means that it is 50%. Okay, then we have part E. I think we had one last part. Yes, part E. Part E says absolute value greater than 0.8. So E, probability of absolute value of C should be greater than 0.8. Okay, so for this particular exercise, you need to remember what the concept of absolute value is. If we do a sketch of this situation, let me copy this, of our normal distribution in this case. What does the absolute value of C represent? Remember that whenever we have absolute value greater than 0.8, this means that C could be greater, let me write this here, C could be less than negative 0.8, right? And at the same time, the value of C can be something greater than positive 0.8, right? Try to think about this, right? If we have a value less than negative 0.8, that for example would be negative 0.9, but we take the absolute value of C, then 0.9 would be greater than 0.8, right? And well, this one's easy, right? If we pick a value greater than 0.8, for example, positive 0.9, then C is automatically greater than that, okay? So this information, let me write this. This is what the absolute value is telling us to work with, okay? So if we do the sketch would look something like this. I'm going to mark negative 0.8. Negative 0.8 could be maybe somewhere around here. Remember, this is only a sketch. Negative 0.8. And positive 0.8 could be somewhere here, for example, right? Positive 0.8. So what are we looking for? We're looking for the values of C which are less than negative 0.8 and at the same time for the values of C that are greater than 0.8. So if we look at our graph, we're actually looking for this region over here. This is where C is less than 0.8, than negative 0.8. And we're also looking for this region over here, which is a region where the values of C are greater than 0.8, okay? Basically, we are not considering this region over here. So, how can we do this? Well, there are different ways we can solve this using the calculator. We could find this independently, and then add up the result. Or an easier way, I think, would be to find this probability, the one in the middle, and then subtract 1 minus that probability, and we will get this and this, right? So let's try doing that. If we do that, we're going to say that the probability of the absolute value of C being greater than 0.8 is equal to 1 minus the probability of being in between these two values, right? So we can find this using the calculator, this probability using the calculator. So we're going to say that probability of absolute value of C greater than 0.8 is equal to 1 minus, and if we go to the calculator to find this interval or this probability, we're going to go back. We need to put in this case as lower negative 0.8, and as the upper boundary we should put positive 0.8, right, to find the probability in the middle. We click on execute, and there we have the probability. So this is 0.576. So once we have done that, we can find the probability of the absolute value of C greater than 0.8, and this would be equal to 0.424. Okay, this is the probability of the absolute value of Z being greater than 0.8. And if you take a look at the graph, you should realize that actually this is not a perfect graph, but this region over here must be the same as this region over here because we're talking about a symmetrical bell-shaped curve. That means that if I want to find the probability of each of these regions independently, I would have to divide this number by 2. 0.424 divided by 2, that's 21.2. That means that this is 21.2% of the information, and this also represents 21.2% of the information. If you want to find, for example, only this region, let me show you that quickly in the calculator before we're done. If you want to find only this region, you could do so, only this region, by going to the calculator. We're going to go back, and we're going to put as lower, we need to put negative infinity, right? Negative 9 times 10 to the power of 99. And as upper, we're going to put 0.8. And we should get as an answer 21.2 or 0.212, right? And that's exactly what we get, you see? 0.212, right? That means that we're doing this correctly. Okay, so I think we're going to leave it here. Yes, I put the... here are the instructions of how to work with each of these exercises in case you don't remember. But I think with the tutorial video you should do fine. But in case you don't remember, you have it here. Okay, these are all the examples covered here. Okay, so for next class we're gonna keep on working with some exercises about normal distribution, but you're gonna see that it's quite easy. It's very mechanical. You're almost always doing the same thing, and then we're gonna cover inverse normal distribution, which is also a very interesting topic about normal distribution. Okay, so I hope this was clear for you people. If not, please let me know. We're gonna clear doubts in future live sessions. Thank you for your attention and see you.